Hello friends, so today I'll show you how to pre-process your data for training a convolutional neural network. Here we will make a dog-cat classifier, and here this dog-cat is our data set. So we'll pre-process the data, and in the next video I'll show you how to train the model using TensorFlow. So this has 5 directories. So this train directory has two directories, cats and dogs, which has images of cats and dogs which we will use to train our our neural network. And here valid has also two directories, and these images we will use to uh, test our data set. And because it is very important to test your data set to see whether your model is not overtrained. Okay, so let's get started. Open in terminal. Okay, so we'll make another directory called dog-cat classifier. Change directory to dog-cat classifier list. Okay, so this is empty. Okay, so another thing, model is empty. Sample. Okay, so sample has some images. Let's see. Okay, let's copy them in here just to see how to pre-process your data. So, okay, so we are in dog-cat classifier. I'll use Jupyter notebook for just show you something. Jupyter notebook. Okay, now upload new Python 2. Okay, so we will import globe, import cv2, that's OpenCV, import matplotlib dot pyplot as plt. Okay, so this globe, why use it? Okay, so let's see. We'll create a list which will have name of images. Images is equal to globe. Oh, so where it is, we are in this directory and we want to see, okay, cats. So dot cats all with the .jpg. Okay, so now see, it has name of all the images in a list. So there it is in cats. Okay, so these are the names which we has here. Okay, so images of 0, that's 0 1 2 3. Okay, so this name. So now if you want to read this image, img is equal to cv2 dot imread images of 0, and we will read it in grayscale format. Okay, so 0, if you are writing here 1, then it will read that image in color form. So we will use 0. Okay, so it has read the image. Now we will see im is equal to cv2 dot resize. What we want to resize, img, in which file, so in which format, or which size, so 50 by 50. So we will read this image and convert it into 50 by 50 image. Okay, so just let me show you. img.shape and im.shape. Oh. So you can see the shape of image was 307 by 500, and when we convert it, now it's in 50 by 50 form. Now just let me show you how. Okay, so fig is equal to plt dot figure abc is equal to fig dot add subplot 2 by 1. Okay, 2 rows 1 column, or 1 by 2, and first image abc dot im show image im. Okay, now, or we can say just image 1 dot show. Now image 2 is equal to fig dot add subplot same 1 comma 2, but second image im2 dot im show img. Okay, plt dot show. Okay, so you can see this is the 50 by 50 image, and this is the original image. So why it is in this color? Just cmap is equal to gray. Here also cmap is equal to gray. So now it's in grayscale image. So this is the original image, and this is the image that we have converted into 50 by 50 image. So now what we have to do is we have to convert all the images in that train directory to this kind of image. Okay, so let's get started with that. Now let me just close this. So we are here in docket classifier. We'll sublime data.py. Okay, so import globe. Now you know what this globe did. Import cv2, import pickle. So what we will do is we will convert all the images into 50 by 50 images, then we will linearize that into 1,2500 of array. So and so we will create an array which will have 2500 columns, and every row indicates one image. So we will linearize all the data, and at the end of that 2500 columns we will add another 2 columns which will show us whether it's a dog or it's a cat. We will use it. So for dog we will use 1,0 the cat. Okay. For cat we will use 0,1. So let me just comment this out. Okay, so we will create the whole data set, and we will save the whole array using pickle. So pickle.dump we will save whole array, and while training the data set we will import that whole array. Define main data or train data. Okay, image size is equal to 50 by 50, and length will be equal to image size into image size. Pics of dogs is equal to globe. Okay, so we are in this particular directory, dogs cat classifier. Okay, so change directory dot takes you to the parent directory. Okay, so after this two directory, I guess we will just have to change one directory, then dogs cats. Okay, and in dogs cat, how many are there? So we'll be go to change train directory. Okay, so what we will do here is dot back, and then dogs cat in that train, and in that train directory dogs. Okay, dogs. Okay, in that dogs all with .jpg form. Okay, so this will give us the whole list which will have names of all the images which are images of dogs. Pics of cats is equal to globe. Same, but cats here. So now okay, we have to import numpy as np. Now train data is equal to np dot zeros total length of data, and how much it will be. So this total length will be equal to length of pics of cats plus length of pics of dogs plus 2. No, not 2. Okay, these are the just number of columns, number of rows. Okay, so total length space length plus 2. So I guess you get that. So it will create empty train data array. Now for pic in pics of dogs, img is equal to cv2 dot imread pic comma 0. Read that image in a grayscale form. img is equal to cv2 dot resize, and what we want to resize img, and img in what format? In image size comma image size. Okay, train data of okay, so we also have to I is equal to 0, because that's how we will read every which row to change. Okay, so I comma 0 to length will be equal to np dot reshape. Okay, np dot reshape, what we want to reshape, img array, and in which form we want to reset it. So we will reset it in 1 comma length. Okay, so it will just make it a linear, make a 50, it will change a 50 by 50 array into 1 comma length, that's image size into image size, that's 2500, 1 comma 2500 length of array. So that's been done, and now last two columns, main train data I comma length is equal to 1, because 1 comma 0, so 0 is already present, so we will change that 2500 and first column into 1, because it starts with 0, that's why 2500, so 0 1 2 and 2500th column. Okay, and I is equal to I plus 1. Okay, so just print here, that's the reading images of dogs. So just an indication where we are in the code while it's running. Print reading images of cats now. So whole thing will same, just pick in pics of cats. Okay, otherwise all the things is same, but here length plus 1 will be equal to 1. And okay, so it's been done. So now after that, just print that now saving the data set. And how we'll save that? Okay, so before saving the data set, we have to shuffle this data set. Okay, otherwise our main model, convolutional neural network model, will just recognize that okay, first are the images of cats and that the images of dogs, so it will not train properly. So what we'll do is np dot shuffle, sorry, np dot random dot shuffle, and what we want to shuffle, train data. It will shuffle the data set along its rows, and that's the main reason why we linearize that whole image. Pickle dot dump train data comma open train data dot p with w, that's right. Okay, so it will open a train data dot p file, and it will save the whole train data array into that file. Return. Okay. So that's been done. Now define test data. For test data, everything will be same, just here it, instead of train, it will be valid. So this dog's cat and valid. Okay, here also valid. Okay, so I guess other than that, Okay, so this, instead of train data, it will be test data, test data, test data, test data. Okay, and what we will save, we will save test data in test data.p. Okay, so I guess all the work is done. Now we have to check whether it's working or not. But my PC has not that much RAM. It has 6 GB RAM, but still, what will happen is the whole data set will be in your RAM. So there are almost 23,000 images. So you can imagine what will happen when 23,000 images will load in your personal computer in that RAM. Everything will it will start hanging. Okay, so what I'll do is I'll see whether it is able to read that 100 images only. 0 to 100. Okay, dogs of 0 to 100, and also cats of 0 to 100. Okay, so I don't, okay, yes, 0 to 100. Okay, so let me just after that run both train data and test data, run both the functions. So for now we'll run just train data. Okay, CNN classifier in that dog cat classifier. Okay, Python data dot, what happens, list of oh, we haven't saved it yet. Okay, saved. Now Python data dot py, let's see what happens. Oh, what, unexpected indent. Well, oh,